Assalamualaikum my students, also here. Welcome you again to our unit. Today our topic is delta method of finding the derivative of a function at some point in its domain. Before going to the method, I hope you are okay and you are doing best with your books. Now this method has another name, that is first principle. First principle or ab initio method. Ab initio method. This is very beautiful method that helps us to find the derivative easily. Now we are going to derive it, but you have to concentrate on word. If we have this as x-axis and this is our y-axis, subtotal f of x, y equals to f of x, and if this is my point x here, this corresponding point here, it is p of x, f of x, and if I will give the increment of this x as del x, for example this is my point x plus del x, so this increment will give us the corresponding increment to this f of x. So for example the point is here, it is, I will take it q, and its coordinates are now x plus del x, f of x plus del x. Now if I draw perpendicular from this p to this q, x plus del x to this line, and when I join this PQ by a chord, clearly this distance PM is equal to del x because it's the increment, and the distance QM, it is actually the increment of this y coordinate, that is del y value. And clearly we know that by the definition of the derivative, f of, if we have this, now we have this y is equal to f of x. Now we know that this increment of this x coordinate and this y coordinate, the ratio of these increments del y divided by del x, we call that ratio as we call that incremental ratio. So this is the incremental ratio. Now this ratio, this and this ratio, clearly this ratio is actually the slope of this PQ. It's actually the slope of chord PQ. Now when I approach this chord PQ, or when I approach this distance del x to 0, so when I give this limit del x to 0, this del y divided by del x, so it will be here limit del x tends to 0, that means limit q tends to p, this q will tend to p, and when this q will come to p, this chord pq will become the tangent at this point p to this curve y. So it will be now this, it will be now slope of tangent, and it will pq will become tangent, so slope of tangent pq at point p, that is x. So we know that this slope of tangent at point x, it is actually the derivative, so it is f dash of x. So this is our ab initio method or first principle, that say the derivative of this function of x, it is actually it is actually equal to limit del x tends to 0, del y divided by del x. But we know that this limit x tends to del x tends to 0, this del y, that is the distance of this this qm, and this qm distance is actually equal to, this qm is equal to the q, this t, for example this is my point t, qt minus mt, that is qt, we have that equal to f of x plus del x. So this del y is actually equal to f of x plus del x. From this f of x del plus x, from this qt distance, we will subtract the distance mt. That is mt. But that distance is equal to the px, and that px is equal to f of x divided by del x. So del x, so it will be del x. So this is our ab initio method that gives us that the derivative of the function at x is equal to limit del x turns to 0, f of x plus del x minus f of x divided by del x. So now we will write the steps of this method. So you write down like this, ab initio. First principle. Step first. What is step first? Put. We have to put the function that we have given as y equals to y. So put y is equal to our function, that is f of x. Step 2. And you have to write down such equation for step 2. What is step 2? Step 2 is you have to give increment this q, you have to make this point q, and to make this point q, you have to give increment to both y and x. Change or give increment to x as del x and y as del y. So we get y plus del y. We are giving the increment of this y as del y is equal to f of x plus del. So second equation. After that, you have to subtract. These are the steps that you have to follow in ab initio method. The formula that I have given you, that this f dash of x is equal to this limit x del x turns to 0, f of x plus del x minus f of x. We are going to derive here from this method. We are going to derive this formula. So this is actually the ab initio method. So here, now we will subtract from this second equation. This first equation we will subtract from second. So subtract the first from second. What we get? We will get y plus del y minus this y equals to f of x plus del f of x plus del x, and then minus this f of x. This y and y will get cancelled. We will get here del y equals to f of x plus del x minus f of x. So we are getting, in step 3 we are getting del y equals to f of x plus del. Now step 4. Step 3, you have to divide by this equation by del x on both sides. So divide on both sides by del x. So what we will get? We will get here del y divided by del x equals to f of x plus del x minus f of x divided by del x. So this is up to here. So third step, and the fourth step you have to step 4. Step 4, you know that the limit by ab initio method, by the method of this that we have analyzed it on this graph, that shows us that the limit del y divided by del x, it is actually the derivative of function at x. So we will take limit del x turns to 0. We get limit del x tends to 0, del y divided by del x is equal to limit del x tends to 0, f of x plus del x minus f of x divided by del x. And we know that this ratio, the ratio del y by dx, it is actually the slope. When we will tend the del x to 0, it is actually the slope of tangent at point P, and the slope of tangent at point P, that is equal to the derivative or differential coefficient, that is f dash of x is equal to a limit del x tends to 0, f of x plus del x, f of x divided by del x. This is our ab initio method to find the derivative of function at point x, or to find the derivative of a function with respect to x. Now this x we can substitute as 1, 2, 3, so on. So for point A, dash of A, we have this equal to limit del tends to 0, a plus del x minus f of A divided by del x. So this is our now. This is our method. So with the help of this method, we will try to find out the derivative of some function. Now, we take that y equals to, you take a function equals to now x square plus 1 divided by x, and for this function you have to find out the derivative of this y or this f of x with respect to x. So by the method of Barth ab initio method, you take it as first. What is our second step? Second step, we have to give increment to both y and x as del x as del y. So now, so which implies y plus del y equals to x plus del x whole square plus 1 divided by x plus del x. I can use directly the formula, but when we will follow the steps like this, we will get this formula, we will get this method clearly. So here it will be my equation second. What is my second step? Second step is we have to subtract from the equation second this equation first. So it will be now subtract first from second. So we will get here y plus del y minus this y equals to x plus del x whole square plus 1 divided by x plus del x, and then minus this x square plus 1 divided by x. So this is my, after here now y and y they will get cancelled, so I will get here del y equals to, check here, it is a plus b whole square. I will give the values of this x plus del x to this x plus del x to both this one and this one. So it will be now x plus del x whole square divided by x plus del x, and then plus 1 divided by x plus del x minus this, I will make it x square divided by x plus 1 divided by x. So now up to here, this is del y equals to, this and this will get cancelled. So we have x plus del x, x plus del x plus 1 divided by x plus del x, and then minus x, and then minus plus minus 1 divided by x. This x and this x will get cancelled. So we will get here del y. So we will get here del y equals to del x plus 1 divided by x plus del x minus 1 divided by x. So up to here, I hope you have understood. Now del y we are getting it equal to del x plus 1 divided by x plus del x minus 1 divided by x. So yes. So here now we will divide. The third step is divide on both sides by del x. So it will be now del y divided by is equal to del x divided by del x, that is 1 plus 1 divided by this del x, that is 1 divided by del x into x plus del. So minus 1 divided by x del x. So this is our now. So you check here, this is del y divided by del x equals to here. Now this is 1 plus solve these 2, so we can give this to multiply by this, so it will be here x del x minus x del x, this minus del x ka square divided by here it is now x del x square, x del x square, and then x plus del. So here this and this will get cancelled. We are getting del y divided by del x equals to 1 plus now 1, and this is now 1, and here it is minus del x square divided by x del x square x plus del. So this del x square and del x square will get cancelled. We are getting del y divided by del x equals to 1 minus, it is very easy method, do 1 divided by, but it is lengthy, 1 minus 1 divided by, here it is x plus del x. So our del y divided by del x, it is equal to 1 minus 1 divided by x into x plus del x. Now the final step is taking limit del x to 0. So limit del x tends to 0, del y divided by del x, it is equal to limit of 1, that is 1, minus limit del x tends to 0, 1 divided by x into x plus del x. So here it will be limit del this thing, that is equal to f dash of x is equal to r y dash, we write here equals to 1 minus limit, we can use the direct method here, so it will be 1 divided by x into x plus del x as 0, that is 0, and it will come out as 1 minus 1 divided by x square. So it will be now x square minus 1 divided by this x square. This is our solution of this. This is the derivative of the function at some point by Ab initio method. Similarly, you can find out another example. The derivative for another example, I will take it as y equals to x square. So this, you have to find out the derivative of this y is equal to f of x by y is equal to this f of x with respect to x. So how you can find? So by you will give push the increment, so it will be y plus del x del y equals to x plus del x ka whole square. Now the second step is to subtract this first from this second, so it will be y plus del y minus this y equals to x plus del x ka whole square minus x square. So this one and this one we are getting del y equals to x plus del x का minus x square. Now the third step is to divide this del y by del x. So it will be del y divided by del x equals to x plus del x का whole square divided by del x minus x square divided by del x. The fourth step is we will now first make it easy here. This is a plus b का whole square, that is a square, that is x square divided by del x plus b square, that is del x square divided by del x, and then we have plus 2ab, that is 2x del x divided by del x, and then we have last minus x square divided by del x. X square plus del x and x square minus del x, they will get cancelled out. So we will get here del y divided by del x equals to this del x will get cancelled. So we are getting here del x plus 2x del x and del x will get 2x. So our increment ratio is equal to this thing del x plus 2x. Now the final method is to give the del x tends to 0. So we will limit del x tends to 0. We will find out del y divided by del x as equals to limit del x plus 2x. So here this will become derivative of f with respect to x, and here it will be now del x by the direct method. This is 0 plus 2x, just 2x. So our derivative of the function at point x, or derivative of function with respect to x, is 2x. This is our method, and inshallah tomorrow we are going to find out some more examples or some more formulas we can also solve by this method, and after that we will find out some methods that are very easy to calculate the derivative of function. Have a good time ahead.